All right, quick map tutorial video. So main things that you're gonna need for plotting points and getting your azimuths and all that stuff is going to be a map pen, which I recommend using black for all your work because the other colors in your case are gonna be red, green, and blue, which are all over the map. So black is the easiest one to figure out and find quickly and everything. And then you're also gonna need your protractor. So I prefer the round protractors versus the square ones. It's a little bit easier to find, and then with the round one you can use this little rope, which helps quite a bit. So the first thing that we're going to look at is our map itself, so you can see that all the grid squares in here are going to line up with your 150,000 square right here. So if you put it over top, matches perfectly. Put it in frame at least. It matches perfectly, so you know what size your map is, and then you know which one of these to use. So on your protractor, you're going to have an X, and then your numbers going to your easting and your northing. So if you look at the actual protractor itself, you have a bunch of words on it, so you know which way to hold it. There's a way to flip it around and do it a little bit quicker, which I'll go into as well. So if you look at the actual map itself, we're going to see that we have the grid zone designation and then the square identification. So that's going to precede all of your grids. So 16 Tango, Fox, Quebec, 1, 2, 3, 4, 5, 6. The higher number of a grid you have, so if it's a 6-digit, 8, 10, so on. If it's an 8-digit, you're going to have a higher accuracy than a 6-digit. So you have a 4-digit grid, which would be 1 square, so it's going to be 1,000 meters. And then a 6-digit is going to be 100 square meters, and 8 is 10 square meters, and a 10 is 1 square meter. So for a lot of stuff, working in 6 or 8 is pretty much going to be the main thing that you're going to want to do. So what we're going to do to figure out a grid of anything is take our protractor oriented the correct way with the X in the bottom left corner, and then the easiest way to read a map is right and up. So you figure out your easting and your northing. So to go right, we have the numbers here, and then they're also all the way at the bottom. So you can see kind of, what you're looking at no matter where. It's a little bit easier to track. So let's say that we need to figure out what this intersection is right here. So let's say that there's a little building at this intersection. We want to figure out what it is. So what we're going to do is we're going to take our protractor and put it there. So for our easting, we are working in the 7-1 grid, because you start from the left, work your way over, you get 7-1, and it's within this box. So because we're continuing to go to the right, it's not 7-2. If we were one over, it'd be 7-2, obviously. So we're in 7-1, and then our height, as you can see here, is going to be 36 because it's within this box. So you go to the right, and you hit a number, and everything within that square going to the right is going to be that number until you hit the next one. Same thing with going up. That's why right and up is important. So we see here that for a 4-digit, it would be in the 7136. But if we want to refine it a little bit, we can see 7-1. I'm going to say 6, 3, 6, 4. It's a little bit hard to see kind of behind the camera and stuff, but we can plot that point as what did I say, 7-1, 6, 3, 6, 4. So remember 16 Tango, Fox, Quebec, 7-1, 6, 3, 6, 4. So that's a really, really, really rough grid. We can refine it a little bit more. And there's an easier method to getting real precise stuff. So let me grab a correction pen. So also you would obviously not write everything on your map. You would, use pen and paper. So the other method to figuring out stuff a little bit easier is going to be if you take your map, or sorry, your protractor, and then you flip it around on the horizontal axes. So what we're going to do here is we're going to put it into our square. Now note this time the X is on the opposite side. We're going to slide this over until our edge here is on the building that we need to figure out the grid for. So what we can do now is we know, okay, we're in the 7-1, and then we look at what number is on the grid itself. So it's like 5.5. So we'll round it up to 6. So 716 364. So we got the same number, but it's a little bit easier to do this than to have, this kind of spot in the middle and try to half-ass line it up and guess. I do a lot of map work stuff, so my guesses are going to be a little bit more accurate just from, using them a lot, but it's like I still mess stuff up too. So we have this spot 716 364, so we know what that grid is. So if you have a GPS or whatever, you can pull your grid, or if you know where you're at by terrain association, you can figure that out. So we'll say that that's going to be our OP. And then let's say that without going into like declination and all that stuff, let's say that we find there's an enemy at this location. So right on this intersection, like on the southwest corner. So what we can do to figure out the direction distance is on our protractor, we have this dot in the center. Actually, let me move this up, make sure everything's still in frame. Okay, so the target's going to be right in this intersection. So what we can do is we can take our dot here and line up everything. So our north-south line here in the center of our protractor is parallel to the grid lines for north-south. So we're working off grid north, which there's 3 different types of north: grid, magnetic, and true. So we'll put our dot in the center, make sure our north and south is pretty parallel. And now with the little rope here, we can put that over the dot that's right there. And then we can bring this up and figure out that the degrees that target is about 191, give or take. So 191 degrees grid. That's important to know because doing your declination, there's going to be a difference between your grid and magnetic azimuth. So 191 degrees grid. And now we need to figure out the distance. So on our protractors, we have 125 and 150,000 for figuring out distance. So obviously left to right, like everything else is red. And we can either work from the target or work from the, ourselves. Either way, we're going to get the same kind of result. So we can look at this and start at the 0 on the target, work back to us, and it's about 650 meters. So it's right between the 6 and the 7. So we haven't quite hit 1K yet. So you see that dot between the 6 and the 7, there's 1K, so 650 meters. So, not degrees, meters. So now we know that target is 191 degrees grid, 650 meters away. So to translate between our grid and magnetic, on the bottom of our map, there's our conversion right here. So GM angle is going to be 8.3 here. And so this says grid convergence. So if you have grid north, and now we're going to magnetic, to convert a magnetic azimuth to a grid azimuth, subtract. To convert a grid to magnetic, add GM angle. So we're going to add 8.3 to 191. So we are looking at about 199 degrees magnetic. So same thing goes for if you shoot your azimuth with a compass. So you see an enemy, you line up your lens at compass, get that, and then you look, okay, subtract 8.3. There's a little hack that you can do on your protractor. You can kind of see the line where you put whatever your GM angle is on like a straight line, so that way when you put it down, instead of lining up your north-south here, you turn that and do that, and then once you figure out where it is in relation to you, you're looking at your magnetic. So I can demonstrate that trick at a different time. So that's a pretty quick down and dirty on how to plot points on a map and then find direction distance.